Alright, so today we'll be talking about normal distributions in Algebra 2b. Alright, and today we'll be talking about discrete probability distribution, okay? So it's a finite number of possible events or values, okay? An example would be binomial probability distributions that we just learned about. Okay, now if this is large enough, this approaches a continuous distribution, which is a continuous probability distribution, which is any value in an interval of real numbers. Okay. Now, normal distribution is data that varies randomly from the mean, and I'll show you examples of all of these in one sec. Okay, and here's the website mathisfun.com on distributions. Data can be distributed, spread out in many ways. It could be more to the left, or more on the right, or it can be all jumbled up. But there are many cases where the data tends to be around a certain value with no bias left or right, and it gets closer to what is called a normal distribution, which is a bell curve-like effect. In other words, about half, a little bit more than a half of your data is in the middle, and then it spreads out as you get around. And there's no bias on top or bottom. Okay, that's called a normal distribution. All right, the bell curve is a normal distribution, and the yellow histogram shows data that follows it closely but not perfectly, which is usual. Okay. All right, now many things closely follow normal distribution. Heights of people, size of things produced by machines, errors in measurements, blood pressure, marks on the test. We say that data is normally distributed. When we say that, this is what we're saying. The normal distribution has the mean equal to the median, which is equal to the mode. Okay, so the most amount of numbers is the same as the median numbers and the mean. Okay, there's symmetry about the center, so there's symmetry. The left half is equal to the right half. And 50% of the values that are going to be greater than the mean, and 50% are going to be less. Okay, now here's a really cool thing. It's called the quincunx, and it talks about how we go from a regular distribution to an actual type of distribution. Okay. All right, so let me move this a little bit so you can actually see this. And let's. All right, and there we go. Oops. There we go. And here's an actual quincunx, and a quincunx is a probability machine, and it's a bimodal situation. So each point the ball has a chance to fall left or right, and it has the same probability. Now if I move this to the right, this probability reminder, it would definitely increase the chances the ball is falling to right. As you can see, this guy's just randomly over here. Okay, and as you can see, the probability of going all the way to the left is very small. Okay, now as you can see, we're already up to 75 items. So if you were to pretend that these were items going through the system, okay, you could actually see that it's starting to look like a normal distribution. So if we sped it up, okay, you could start to see the actual table down at the bottom, the actual histogram down at the bottom start to represent an actual normal distribution curve. So this is actually kind of cool that you can set this up like this. Alright, now if you go to it, it's actually a whole lot of fun. You can actually recreate it. You can actually increase the row size. You can increase the probability to one side or another. But the key is that at any time I go to a number that's really large, the closer and closer this normal distribution is going to be, which is what we just talked about. Alright, so the discrete probability distribution with the probability of being success or the probability of being a failure, that was what the quincunx was actually showing you guys, and it was going through several variations of it. Okay, and as we increase more and more in size of this, this is going to approach a continuous probability distribution, which is going to look very normal. Okay, over time, when we're definitely talking about the probability being even. Now, if you wanted to have the probability be a little bit more to one side or the other, you could do that, and it would actually show you. Okay, now I'm going to show you exactly what normal distribution is going to look like and how you're going to use it to help you out in algebra. Okay, so we talked about the standard deviation as the measure of how spread out numbers are. Okay, when we calculate the standard deviation, we find that generally 68% of values within normal distribution are within one standard deviation above or below the mean. 95% are within 2 standard deviations, and 97% are within 3 standard deviations. Okay, so for example, 95% of students at school are between 1 meter and 1.7 meters tall. Assuming that this data is normally distributed, can you calculate the mean and standard deviation? So the mean is halfway between 1.1 and 1.7, so we get 1.4. 95% is 2 standard deviations to either side, a total of 4 standard deviations total. Okay, so if we divide that 1 standard deviation, which would be 1.1 minus 1.7 minus 1.1 divided by 4, that would be 0.15 meters. Okay, and then you could actually draw out a normal curve for it. Okay, it is good to know that standard deviation, because we can say that the value is likely to be within 1 standard deviation, very likely to be within 2, and almost certainly to be within 3. As a matter of fact, there was a story about the scientists who were trying to discover the beginning of all existence with the Big Bang, and they found out that to within certainty of 5 sigma, or 5 standard deviations, they found the Big Bang that actually happened. Okay, so some really cool stuff that actually works with right there. And I love mathisfun.com because they have a great bell curve that is the standard normal distribution. Now the standard form is if you superimposed, here let me zoom up, you can actually see it, it's really cool, is if you superimpose the normal distribution upon the standard normal, and the standard normal would just have the standard deviations instead of the actual score. So instead of the mean being in the middle, it would be 0. And on either side would be the numbers within it. So, but anyways, back down to the actual thing. Alright, there you go. There's the bell curve. This is the lovely thing about this. You might want to screenshot this. This will save your butt whenever you're dealing with it. You have your z-scores right here. So if you choose to go in statistics, you can actually look at this real fast and find it. Your standard deviations underneath it with your half even marked out for you. So for example, if you were looking for all the data in between 0 and 0.5 standard deviations above the mean, that would be 19.1% of the total amount of information would be in there. Okay, and then the cumulative percentage is down here, so you could add it up. So if you're looking, and this will tell you percentiles. So if you ever wondered, like, man, I'm in the 99th percentile, how good am I? You're about 2.2 standard deviations above the average person. Or if you're like, you know, I learned about my cousin, he's within the 10 percentile for weight when he was a baby, which is normal for kids. You know, every kid is going to be that way. That means it's about negative 1.225 at the standard deviations below the mean. So it's actually kind of interesting to take a look at this stuff and see it. Okay. Alright, that is it pretty much for standard deviations. Use this curve like the back of your hand and make sure you know how to do z-scores. Z-scores are actually ways to actually find you the actual standard deviation you are from the mean. Okay, and so real fast, a z-score is your actual point minus the mean divided by sigma, and you can actually find your z-score. Okay, and it helps us make decisions about data. Okay, so you can actually see, like, if these are the scores people got out of 60 questions on a test. Alright, as you can see, they're all pretty low, but which one was really the worst? Well, these two guys were really the worst, the 15 and the 14. Okay, and then he has z-scores to back this up. Okay, alright, that's it for normal distributions and standard normal distributions. I'll talk to you later. Bye.